for this video, we are going to talk about triangle congruence. So I have here an exercise prepared for you. So there are actually 5 items. So all we have to do is identify which postulate will prove the congruence of the triangles given. So let's start with number 1 or item 1. So it says here that given the following conditions, our conditions are again the following. So we have angle A is congruent to angle E. So this is congruent to this, right? And C is the midpoint of BD. So again, remember, when you talk about midpoint, it will divide a segment into 2 equal parts. So if this is BD, and C is the midpoint, that means to say that from CD, this one is congruent to this one. Alright, so we have, because of this one, we will have BD, no, that's not BD, that's BC. BC is equal or congruent to CD. So from this, we have an angle, and a side and a side. And based from this figure, angle B and angle C are right angles. Now, right angles are congruent, right? So, right angles are congruent. So, we actually have S. So, that is actually the correct answer will be letter A. AAS postulate. So, we have 2 angles and a non-included side. Next item. So, given BC is congruent to CD. So BC, this one, is congruent to this. And we have triangle, angle A is congruent to angle A1, is congruent to angle 2. So this is congruent to this. And then again, we have here right angles. So right angles are again congruent to each other. So we have A, S, A. That will give us letter C as the correct answer. Next, we have AB is congruent to EC. This is congruent to this. And then, segment EC, this one, bisects BD. So again, when we have a bisector, the same with midpoint. So bisector is a line segment that will divide another segment into 2 equal parts. So 2 equal parts. So meaning to say this and this are congruent. And again, right angles are congruent. So we have S, A, S. So what letter is that? That is letter B for item 3. Item number 4. Segment AB, this is congruent to DC. This one. And then AD is congruent to BC. And again, this is congruent to itself, right? That is from the reflexive property, right? Property. So we actually have what? We have side, and another side. So this is S, S, S. So we have letter D. Then the last one. Alright. AB segment AB is parallel to DC. So this is parallel to this. And AD, this one, is parallel to BC as well. So what do we have here? Alright, if you can still recall, if we have two parallel lines and it is being cut by a transversal, we actually form different angles, right? And if these two, this in this line or segment are parallel, and this will be our transversal, we have what we call this one, the alternate interior angle. Right, so we have the alternate interior. They're actually congruent, right? So this is congruent to this, and this is also congruent to this part. And again, this segment is congruent to itself. So this is our side. So we have what? We have angle, side, angle. So what letter is that? That is actually letter C. And then if we are going to define this polygon, this is actually a parallelogram, right? But then again, it's not stated in the problem that this is a parallelogram, so we will not assume, but the properties here are the properties of a parallelogram.